Okay, so today's topic is reflection. So we'll be basically discussing about the meaning of reflection, type of mirror, and mirror images. Okay, and the mirror formula. So derivation is not part of our syllabus now, but you have to understand the meaning of reflection now. Okay, so let's move forward. Okay, so what is reflection? So when light traveling in a when light is traveling in a medium and it bounces back into the same medium, so when light is traveling in a medium and it bounces back in the same medium, suppose this is your reflecting surface, and suppose light is traveling like this and it is bouncing back in the same medium, then this phenomena is known as reflection. Okay, remember, in reflection, neither your velocity changes, neither your nor your frequency changes. Okay, and at this point is called as point of incidence. So at point of incidence, we draw a normal. So this is your angle of incidence. This is your angle of reflection. Look, you can see in this diagram. This is your incident ray. This is point of incidence. This is normal reflected ray. And this is angle of incidence. This is angle of reflection. Remember, the angles are always made with the normal. So when light traveling in a medium strikes a reflecting surface, it goes back into the same medium obeying certain law. And this phenomenon is reflection of light. And there are two laws of reflection. First is that angle of incidence is equal to angle of reflection. And second, all three, like the incident ray, the normal, and the reflected ray, they lie in the same plane. But you have to remember that in reflection, angle of incidence is equal to angle of reflection. Now, there's one important topic here is angle of deviation. How much did the light deviated? So understand it like this. Suppose this is a mirror, and suppose this is your incident ray, and suppose this is normal, and this is your angle of incidence I, and this is angle of reflection R. So if there would be no reflection, then the light would go like this, but the light is going in this direction. So this is your angle of deviation. And what will be the value of this? This is pi minus I plus R. I want to calculate this angle, but I is equal to R. So deviation can be written as pi minus 2I. Please remember this formula for deviation when there is reflection in the medium. Okay, now let's come to spherical mirrors. So what are spherical mirrors? So basically spherical mirrors are those which are part of a sphere. Okay, so this is concave spherical mirror where the inner side is reflecting. The inner side is reflecting in nature. This is pole, that is center of mirror. This is C, that is center of curvature. This is F, that is focal length. So PF will be equal to F and PC will be equal to R. And remember, focal length is basically radius of curvature divided by 2. And what is radius of curvature? The distance between center of curvature and pole is called as radius of curvature. Similarly, we have convex spherical mirror. In this case, the outer side is reflecting. In this case, the outer side is reflecting. In concave, the inner side is reflecting. And center of curvature, here, focus is here, pole is here. In this case also, focal length will be R by 2. But remember that in concave mirror, the inner side is reflecting, and in convex mirror, the outer side is reflecting. Okay, now let's come to mirror formula. Suppose we have a concave mirror, and suppose this is pole, focus, center, and here is your object. So one light will go like this, so parallel, and it will pass through focus. Another light can go like this, light from focus, and it will pass like this. So suppose this is your image. So the distance of object from pole is basically u. So u is what? U is object distance. V is image distance. So u is object distance, V is image distance, F is focal length. Okay, but remember one thing. If light is traveling in this direction, so anything measured from pole in the direction of light will be positive. Anything measured from pole in the direction opposite will be negative. So in this case, U will be negative, V will be negative, and F will also be negative because focus is also on backward side, object is on backward side, and image is on backward side. All three will be negative, and they will be related by this formula, that is 1 upon V plus 1 upon U equal to 1 upon F. And remember, distances are always measured from the pole of the mirror. And there's an important thing, that is magnification. it is given by height of object by height of image by height of object, and its value is also given by minus v by u. And remember, when image formed is real, the magnification is negative, and when the image formed is virtual, the magnification will be positive. So if magnification is negative, image is inverted, real and inverted. If magnification is positive, image is virtual and erect. Please remember this thing. And if suppose the height of image is more than height of object, then it will be enlarged image. Suppose height of image is less than height of object, it will be diminished, and both are of same size, then it will be same size image. Okay, but please remember this formula: 1 upon v plus 1 upon u equal to 1 upon f. I'll discuss the sign convention again. Okay, so we have 6 diagrams for concave mirror and only 2 diagrams for convex mirror. So if you'll see, in concave mirror, in this case, the image is real, inverted and point sized. If you'll see, the image is a point. So if object is an infinity, the image will be a point. In second case, if you'll see, the object is beyond C and the image is between C and F. This is real, inverted. If you can see, it is diminished image. And in this case also, U will be negative, V will be negative, F will be negative. In third case, if you'll see, the object and image are of same size, but the image is real, inverted and same size. And in this case also, all three will be negative. In this case, if you'll see, this is object, this is image. Image is real, inverted and enlarged because size of image is more than size of object. And in this case also, U will be negative because U is also in backward direction. V will be negative and F will be negative. In this case, the image will be formed at infinity. And in last case, if you'll see, the object is here, the image is here, but the image is in this direction. So V will be positive, U will be negative, F will be negative, and the image is virtual, erected, enlarged. Okay, so concave mirror forms virtual and erect image, which will be enlarged in nature. For convex mirror, we only have two ray diagrams. Like first one will be this. Suppose this is a convex mirror, and suppose light is coming from infinity. So light will reflect like this. And if you will extend them, then the image will be formed at focus. In this case, if you will see, the V is positive and the F is positive, U is minus infinity. Okay, so V is positive because image is formed in this direction. F is positive because focal length is also in this direction. V will be negative because object is behind. And except this ray diagram, there is only one another ray diagram. Suppose object is placed at any arbitrary point. So the image will always form between pole and focus of the mirror. And the image will always be virtual, erect, and diminished. So in the case of convex mirror, the image will be virtual, erect, and diminished, and it will be between pole and focus of the convex mirror. So these are the ray diagrams for concave and convex mirror. Please remember the mirror formula, the formula for magnification, and the formula for deviation. Okay.